Hey, welcome back, AP Calculus students. Today we're looking at 5.2 mean value theorem part 2. So two things that we're going to look at right off the bat. If f prime is greater than 0, then f increases on AB. And if f prime is less than 0, then it decreases on AB. So this just means positive and negative. Okay, so let's kind of look at what that means. So if we look at x squared, right, we're super familiar with it. It's a parabola. Our vertex is at 0, 0. So we can tell that, okay, this is decreasing from negative infinity all the way to we hit the vertex, right? So decreasing. And then on the other side of the vertex, it's constantly increasing. So it's increasing from 0 to infinity, and it's decreasing from negative infinity to 0. Okay, so let's verify what we just did using our rules up top. So if we did the derivative, right, these are f primes. So derivative of 2x, x squared is 2x. So we notice that this is going to be negative for any negative values, right? And then we know it's going to be positive for any positive values of x, right? Because if I plug in a negative in here, then we always come out with a negative. If I plug a positive in there, then we always come out with a positive. A 0 is neither, right? Because it's not positive or negative. So that verifies that the derivative tells us about where we're increasing or decreasing by its sign. Okay, for this one, it's asking us to look at x cubed minus 4x. So we're trying to do the same thing, right? We're trying to figure out where it's increasing, where it's decreasing. So we're going to do, the first thing is derive. So we're doing the derivative with respect to x of x cubed minus 4x. And we know that's going to be equal to 3x squared minus 4. Okay, so what we're trying to do here is we're going to find the boundary. So we're going to find where the derivative is equal to 0. So we're going to set it equal to 0. We're going to solve it. So x is going to be equal to positive negative square root 4/3. And just for our reference, that's going to be equal to positive and negative 1.155. Okay, so what we're going to do here is we're going to set a chart up. So we can figure out what's going on here. So we're going to set up boundaries. This is going to be negative radical 4/3, and this is going to be positive radical 4/3. The reason why we did this is so we know what numbers to choose to plug back into our derivative. So we know that the derivative is 3x squared minus 4. So let's choose a value in this area here. So I'm going to choose, because this is a negative 1.155, let's choose negative 2 and input into our derivative. So 3 times negative 2 squared is 4. That's 12 minus 4 is 8. So this is a positive in here. Let's do the same thing. Let's choose 0, because 0 is definitely between negative 1.155 and positive 1.155. So 3 times 0 squared minus 4. 0 minus 4 is negative, right? And then when we do the last part, let's choose a number bigger than 1.155. So let's do 2. 2 squared is 4, 3 times 4 is 12, 12 minus 4 is 8, which is positive. So here we know that the interval where it's decreasing, it's between negative square root 4/3 and positive square root 4/3. And it's increasing on the outside, so from negative infinity to negative square root 4/3. And then again at square root 4/3 to infinity. Okay, what corollary 3 says is functions with the same derivative differ by a constant. So this is going to get super important in the second semester when we're talking about antiderivatives, which is the reverse of our derivatives. So there's a little note here that when going backwards from derivative, we must take into account any constant as a plus c. So let's look at here. So if we do the derivative with respect to x of x squared plus 1, well, the 1 derives out every time, right? So we get 2x. Same thing happens here. So we have x squared again. The 3 derives out, so the derivative is the same, right? 2x. And then same with the last part. Even though we have a minus 100, our derivative is the same. So we can have different functions that look exactly like, well, whose derivatives are exactly alike. And they all differ, right? The only difference is the constant that's added on. So yeah, anytime we go backwards, we need to make sure we put a plus c on there. And this next type of problem shows us exactly why. All right, so it's saying find the function f whose derivative is sine x and whose graph passes through 0, 2. Okay, so they're giving us some information here. So, well, if the derivative is sine, right, the cosine's derivative is negative sine. So if we have a negative to start with, then we have a sine, right? So the derivative of negative cosine would be positive sine. Now what we also need to do here is we're going to have to say that, so we found the function, right? So it's negative cosine x, but we have to say plus c. Right, so that would be our function, y equals negative cosine x plus c. They're also giving us this information. It says whose graph passes through 0, 2. So what we're going to do here is, remember that we have an x and a y. We're going to substitute our x and our y. So we have 2 here. So we substitute x and y. Minus cosine, our x is 0, plus c. So it's asking us to find the c. Or what we're trying to do here is trying to find the c. So the cosine at 0 is 1. So negative 1 plus c. And then we're going to solve this for c. Okay, so now we fill back in here. So our function should look like y equals negative cosine x plus 3. So when they give us the specific graph that they want us to go through, then we have to find the value for c. And what it looks like is if I graphed a bunch of cosines, or they should actually be negative cosines, but you understand what I'm saying. These are all graphs with the same derivative because they only differ what this could be like a plus 1, this could be a plus 0, this could be a minus 2, right? Added or subtracted onto our cosine. But when they're saying find this specific one, right, what they're asking us to do is give us the one function whose derivative is sine x, but also that passes through that one point. So this one may be the only one that crosses through that point, while the other ones do not. So you just have to be very specific. We have to put the plus c and then plug our information in to solve for c. Okay, that's it for today. Good job.